Hello everyone, in the previous lecture we have discussed about Arrhenius equation of rate constant and half-life of reaction. In this lecture we will discuss about the mechanism of reaction, order of reaction and some other terms. Now, what is the mechanism of reaction? It is a sequence of steps. Sequence of steps which make a complete reaction is known as mechanism of reaction. Actually, mechanism of reaction is nothing but these are sequence of steps. It can be 3 step, 2 step, 4 step or some other step. For example, generally if there is a reaction in which, suppose in a reaction A converted into B, but the B is intermediate and it is for very short time, and the B suddenly the B converted into C. So suppose in a reaction A is converted into C. This is the overall reaction and this is the mechanism of reaction. It is consists of two, this mechanism consists of two steps. These are the sequence of step, one step and the other step. In the first step the reactant form intermediate B. In the second step the intermediate consume and form the product C. So the overall reaction is A converted into C, and this is the mechanism of these two steps show the mechanism of reaction, that how the reaction took place. So we can also write this, the overall reaction can also be written as, we can add this side this term cancel with this term, it is very small. The intermediate cancels, actually intermediate consume in the reaction and we do not consider it. So A converted into C. Now what are the intermediate? These are molecules or radicals or products which are produced in one reaction. These can be radical or molecules or molecules which generate in one reaction. Suppose A intermediate B is produced and this B intermediate is consumed in the other reaction and form the in first step the intermediate is produced, in the second step the intermediate is consumed and produced and C is produced. So actually what are the intermediate? These are the radical or molecules which are produced in one reaction and consumed in the other reactions. Now as we what is elementary reaction? Suppose a reaction in which A plus B combine and form C. Now what is the rate law for this reaction? The rate law for this reaction can be written as the rate of consumption of A is equal to K into concentration of A into concentration of B to the power of 1. Now the rate law for this reaction is written in term of stoichiometric equation form. This rate law is written in the form of stoichiometric form. The order of reaction with respect to A is 1, which is stoichiometric coefficient, which is here, is 1. Now the order of reaction with respect to component B is also first order, which is here 1. So the order of reaction for elementary reaction is nothing but it is the stoichiometric coefficient. Suppose we have elementary reaction in which A converted into B, and the rate law for this reaction will be written as K C A concentration of A to the power of 1. Now this power 1 is nothing but the stoichiometric coefficient of this reactant. So such type of reaction in which the rate law is written in this form is known as elementary reaction. In elementary reaction, the rate law is equal to the stoichiometric form of the reaction. The stoichiometric equation is equal to the rate law in the case of elementary reaction. Now, and suppose this is the rate and it is KCACB. Suppose this rate law is written for this elementary reaction into C. So these are the stoichiometric coefficient, and the power of concentration is nothing but it is the stoichiometric coefficient. And such type of reaction whose rate law is written in term of stoichiometric coefficient is known as elementary reaction. This type of reaction is known as elementary reaction, and the power of concentration is nothing but it is order of reaction. It is order of reaction is nothing but it is the power of concentration term. Concentration, nothing but power of concentration. Now this reaction is first order with respect to A, similarly first order with respect to B, and the overall order is nothing but sum of these two order, 1 plus 1, which is 2, which is the overall order is second order. So suppose we have another reaction, which is 2B plus C equal to P. Now suppose if this is elementary reaction, then we will write the rate for this reaction will be KCB, concentration of C to the power 1. So the order of reaction with respect to term B will be 2. Order is denoted by N. So N is equal to 2 with respect to B. The order of reaction is 2. Similarly, the order of reaction with respect to C is 1, and the overall order of reaction is 1 plus 2, which is 3. This is the overall order. This is 3. 2 plus 1 is the overall order of reaction. This is the overall order of reaction. These are the elementary reaction. Now there are some type of reaction. Suppose A plus B C. If the rate law is like this type, suppose rate law is like this type, then this type, suppose we have a reaction and its rate law is like this type. This rate law is suppose the rate law in this rate law the concentration, the power of concentration is not equal to the stoichiometric coefficient. This rate law is obtained experimentally. the rate law is obtained. The order of reaction and rate law and mechanism, all these terms can be obtained experimentally. We obtained it experimentally. The order of reaction, the rate of reaction, the mechanism of reaction, all these can be obtained from experiments. So if someone has done some experiment and he obtained the rate law like this type for this reaction, so in this rate law the power of concentration is not equal to the stoichiometric coefficient. So this type of reaction is known as non-elementary reaction. Now, as we have already discussed, suppose we have a reaction in which A is converted into C. Now if we write, suppose the mechanism of this reaction is, in first step intermediate is produced, and the second step the intermediate is consumed, and intermediate is consumed to C, and C is produced in the second step. In the first step intermediate is produced, in the second step intermediate is consumed and C is produced. So the elementary step, the single step, each step of this reaction is known as each step of this mechanism is called the elementary reaction. This is one elementary reaction and this is the other elementary reaction. Each step of the reaction mechanism is known as elementary step or elementary reaction. So this is first elementary reaction and this is the second elementary reaction. So second elementary reaction. So each step of the reaction mechanism is known as elementary step or elementary reaction. Now if we have a reaction, suppose the same reaction in which A is converted into C. In the first step intermediate is produced, in the second step intermediate is consumed. Suppose this reaction took place in 20 minutes. And suppose the B consumed very quickly. Suppose in the reaction A converted into intermediate in 20 minutes, but in the second step the intermediate consumed very quickly, like in 2 minutes. Suppose 2 minutes or 1 minute. Then the slowest step of this reaction will be known as, the slowest step of this mechanism will be called as rate determined step. Rate determined step. The slowest step of reaction mechanism is known as the rate determined step, and the rate of reaction can be obtained from this slowest step. The rate of reaction depends on this slowest step. This step took place in 20 minutes and this step took place in 2 minutes. So the slowest step, this is the slowest step, and the rate depends on this slowest step, and rate and order of reaction can be obtained from this slow step of the reaction, and it is called the rate determined step. Now what is the molecularity? For example, what is the molecularity of the reaction? What is molecularity of reaction? Suppose we have the same reaction in which A is converted into C, the overall reaction. Suppose this is the, in the first step A converted into B, in the second step B is converted into C. So molecularity is nothing but it is the number of reactant molecule of the elementary step. Suppose this is first elementary reaction, this is the second elementary reaction, this is the second reaction. Suppose this is the mechanism of reaction, and this mechanism of reaction consists of two steps, first step and the second step, and these two are the elementary reaction. Suppose now what is the molecularity of reaction? It is nothing but the number of reactant molecule involved in a reaction, in elementary reaction. So the reactant molecule involved in this reaction is 1. So molecularity of this reaction is 1. Molecularity is 1. Similarly, one molecule involved in this reaction, so the molecularity of this reaction is also 1. So suppose we have a reaction in which A into C, in which A converted into C and the C with B to form D. Now the D, now 2D to E and form F. So the molecularity of this reaction is, now what is the molecularity? It is 1 plus 1. Molecularity of this reaction is 2. Similarly, 1 plus 1, the number of reactant molecule which involved in this reaction is 2. Molecularity of this reaction is 2. It is bi-molecular reaction. If there is one molecule involved, it will be unimolecular reactions. It is bi-molecular reaction. Similarly, there are three reactant molecule involved in this elementary reaction. So it is termolecular, trimolecular, or termolecular reaction. So this is the molecularity of reaction. Now the molecularity of reaction can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It is any integer. It can be any integer like 1, 2, 3. It cannot be in fraction form, like it cannot be 1 over 2, it cannot be 1, 3 over 4. Molecularity cannot be in fraction form, but it is always in integer form, because it show the mechanism of reaction, and in every single step 1 or 2 or 3 molecules involves in the reaction mechanism step. So molecularity is integer. It can be 1, 2, 3, 4 or any natural number. And the order of reaction, which is the power of concentration, like Ca, Cb. Suppose this is the rate law, this K rate constant, suppose this is 2, 1. So this is the power of concentration is order. The order of reaction can be whole number, it can be whole number 0, 1, 2. It can be fractional, it can be 1 over 2, it can be 3 over 4. So order can be in fraction form, but molecularity cannot be in fraction form. So this is the molecularity and order of reaction. Suppose suppose we have a reaction in which A is converted into A plus B converted into C plus D. Suppose we have 2A. So suppose the rate law of this reaction is K. Suppose this is elementary reaction, so Ca2 Cb1. Now what will be the overall order of this reaction? The overall order of this reaction will be 2 plus 1. It will be 3. Similarly, the order of reaction with respect to A will be 2. Order of reaction with respect to B will be 2 and the overall order will be 3. So these are all about the order, molecularity and rate constant and mechanism of reaction.